Well, hello everyone, and welcome back. This is, believe it or not, our last session for the year for grade 3. We are now on session 5, and we will be looking at just a couple of things that we deferred to the last session, but also maybe a way to keep revisiting those outcomes now that you're going to be reporting on. So we've spent kind of the year bridging, going back, reviewing, always building on, adding on the goal that we're going to be meeting with each of the outcomes. But now we're at a point where we should be at those levels, and you're really just reviewing for mastery in order to fill that final assessment to say, yes, they have met or not met that outcome. So I'll try and share some ideas with you today, some links that you can go to, but want to spend a little bit of time looking again at those fractions. Also want to spend a little bit of time looking at statistics, because we did put that one as kind of our last piece to review and to make sure that, if not common language, is at least being used now throughout. So let's get started. Let's begin with our land acknowledgement. We respectfully acknowledge that we are situated on traditional lands across the province of Alberta, home to many First Nations, including the Cree, Blackfoot, Métis, Nakota Sioux, Saulteaux, Inuit, and many others whose history, languages, and cultures continue to influence our vibrant community. So we did look at these April ones already, but I just want to bring them into play just so that you can remind yourself of what we did look at in session 4. And that we were still sort of finishing up on making sure that their math facts to 100 are solidified. They've got good strategies to figure out those answers, that they're not sort of just straight memorization, right? That they've learned them through different arrays. They've learned them through different games. They've learned them through grid paper. They've learned them through groupings, additions, multiple additions, addition facts that they've had, right? So all of those pieces, we want to make sure they have a strategy. It was not just, here's the table and we're going to memorize it. So we're continuing to work on that, because those are important pieces for us to look at, and we're wanting them to be able to master them. And remember that fluency doesn't necessarily mean speed. It's nice if they have instant recall, and that's really our goal when we master our math facts, but it's not about speed necessarily. We also don't want to see them just counting on their hands to get an answer either. So it's working on practicing, making them, committing them to memory, making them, it's sort of a quick response, an instant response. Looking both at multiplication facts also will tie into our division facts. Do they know how to take a multiplication table and turn it into a division table, right? The reverse of it. So always looking at both sides and making sure that they're fluent in those. But the N4 is the one that we said we would spend a little bit of time revisiting. We have spent a fair bit of time talking about fractions already, but we want to talk about fractions in the terms of no bridging now. So we're really looking on, do they understand what a fraction is? Do they understand that it's a relationship? And remember, that's the word we talked about from kindergarten up, is there is no rush to show them the symbolic. There is no rush to write something as 1/2 or 2 or 5 and just say the top number is called the numerator. It's a number of parts. The bottom number is the denominator. It's the total number of parts. All true, but that's just really an algorithm, a way of saying something, a way of telling you what it is. Have we unpacked it so they understand what it is? And that's our goal. And I have said this more than once already, and just want to revisit that again, that unit fraction that you are building in grade 3 is absolutely critical for them to learn for grade 4 and to unpack multiplication, addition, subtraction, all of those pieces that they see in grade 5, 6. So we can't just give surface level talk to unit fractions. They really need to understand them, model them, put them on a number line, count with them, realize that they're numbers, not just something we call a fraction, but they haven't connected that it's a number. I can't really kind of overstate the importance of really knowing what a unit fraction is. And it goes beyond just, as I've said before, a circle that might have already in a bunch of circles on a worksheet or a bunch of shapes. And we say, can you shade in one? Well, of course I can. I can color. That's not a problem. And then can you tell me what you've colored in? Well, I can count the number of pieces. But because I can say 1 out of the total number of pieces that I colored, That doesn't mean I understand a unit fraction. So we really, really want to unpack that. And so we're going to walk on, talk a little bit about that again. And then I've got a link here for you. I won't go into it right now, but remember K5 isn't one that we're not new to. We've used them before, but they have a great resource on unit fractions that you might want to have a look at. So again, when we talk about fractions, we can talk about it in terms of where can I now just keep revisiting my work that I did with unit fractions? How do I skip count with a unit fraction? How do I show them? How do I get to a whole by counting on a number line by a unit fraction? All of those different pieces could have been done by all the pieces we've looked at before. So this slide that I'm showing you right now came from session 4, right? It's not new, we've done it before. We looked at fractions within Braining Camp. There was the code if you hadn't gone in. We looked at Cuisenaire rods again, building a unit fraction on a Cuisenaire rod. And then once I understand how to build the unit fraction on the Cuisenaire rod, then I could put 2 of those pieces on top. And then I can reflect it as more than just a unit fraction. But I have to understand what a unit fraction is that I'm building as I make it. So if you're not remembering either when we did it with money, session 3 is where we put money onto a number line. We leveraged the skip counting by money. We leveraged their understanding of how many different coins in a loonie, in this case, 100 cents. We used dimes to start. We did nickels, we did pennies, we did quarters. That's everyday real world context. That's a real way for me to link unit fractions for a student. But it's also learning the money piece that I need them to learn at the same time. Remember, money was a concept and a tool. So this was the work that we did in session 3. We showed them and we reminded them that the minute we put 0 onto a number line, 0 on a number line has a purpose, not just because that's a starting point, but it indicates that the 0 to the very first place on the number line that we are going to tells me the length of distance from 0 to that point. And then if I'm going to be counting by the same amount, then every subsequent point thereafter would be the same distance. So if I use the dime as my marker, this is how much 10 cents looks like. Each jump would be the same distance. This was our first dime out of a possible 10. And although it looks like we've written it as a fraction, we never said it as numerator denominator, we simply said it was a relationship. This is the first dime out of a possible 10 to make 100 cents or 1 loonie. This was our second dime out of a possible 10. Some students write it as 2 bracket 1/10. Some students write it as 2 over 10. Either way is how they're thinking it through. They are jumping by a unit fraction. Each of these is 1/10 of the line long. And I jump along, jump along, jump along 10 times till I get to 100 cents. So this is what it looked like when we did our work in unit 3 or session 3, where we talked about putting them all on a number line. And why was that even important, is putting them all on the same number line? Then I could even have a conversation of at 50, what is 50 cents in the 100? Well, it's the halfway mark, right? It's the halfway mark. And what did we see about the fractions that we saw, that we wrote at that halfway mark? And then we started to talk about things like an equivalent fraction. So it was how we developed our work forward from there. We also did, what if we had 0 to 1? So all of these lines went 0 to 1. And we wanted to practice with them. I made 1 hop, I made a second hop, but the hop was the same length. Well, if I only made 2 hops, this is the first out of 2, this is the second out of 2. That means this is the first out of 2, or 1/2. So we're interpreting it as 1/2. You and I as adults know exactly what 1/2 means, but as a student, I might not know yet how that contextually fits. And that was the purpose of this sheet as well. So now I've got different hops. And we asked the students to fill this in. We didn't do that for them. We said, how many hops are there on the line? Well, there's 1, 2, 3. So this would be my first out of third, my second out of third, my third out of a third. So some students, remember I said, will say it's my second 1/3 hop, and that's how they write it. Or some won't, it's my second third hop, second out of two, second hop out of third, sorry. So this is really kind of a nice way, because when we get into grade 5 and we talk about multiplying, or grade 6, we talk about multiplying fractions. Well, this gets me to that whole notion that a whole number times a proper fraction. I multiply the whole number by the numerator, right? We've talked about numerators and denominators extensively then, and they know what those words mean. That's why I get 2/3. So this is the stepping stone to getting to all that work that they need to do down the road. And that's why I say the importance of this understanding a unit fraction to getting to even that conversation about multiplication will make sense to them afterwards. A student should, in the end, be able to look at any fraction, like 7/8, and say those were 7 1/8 jumps. One of your outcomes is that any fraction can be expressed as a number of unit fractions. 7/8 would be 7 1/8 hops down the number line. That's how students should be able to unpack the understanding of a unit fraction to any size fraction. So in this case, we even aligned in some of them, if any one of these lines would represent money. So we went back to it. Well, half could be 50 cents. Quarter could be the quarter. That's an easy one. A fifth, that one took kids a little while to think about. What do we have that would take 5 to make a whole? So in this case, we said, well, that could be a $20 bill if one whole was 100, if that's what you wanted to do. And so again, we talk about those pieces. If I know how to do those jumps, then getting to an improper fraction is an easy way for me to have that conversation about, well, they're not always going to end with the same number at the top. It's possible for the number on the top to be larger. That numerator could get larger than the denominator. So again, you want to talk about these. We want to have ways of coming up. We want to be able to address in your current one that we're still trying to practice between now and June for assessment in the understanding. The size of the parts and the total number of parts in the whole are inversely related. That's one of your outcomes. Now, that's a mouthful. Fractions are not everybody's ball game. Not everybody loves fractions, and not even adults love fractions, right? And I'm sure there's lots of you that are teaching them saying, this is not my most favorite place to be. But if I wanted to actually say that to a student, and I'm not even strong in fractions, and you said to me, did you know that the size of the parts and the total number of parts of equal parts are inversely proportional to the size of the whole? Wow, that's a big ask for a student. So I want to show you a way that we can do that with simple paper folding. Now, what you could do is stop the video right now. And what I'd like you to do is you could take scrap pieces of paper. I'm looking for 8.5 by 11, like a normal piece of paper. And when you get, I just took a yellow, but you can take scrap paper because you're just going to probably throw them away at the end anyway. So it doesn't matter if it has some writing on it, as long as you can read something that you write on it, you're good. So here's what you're going to look for. Then you can pause the video, go get them and come back again. So this is an 8.5. I cut it on the 11 side, the long side of your paper. I simply cut them into strips of about an inch. Okay, it doesn't matter how big it is, as long as your strips are the same length and about the same size. That'll make it easy for you. So go ahead and pause the video. You need about, I would say 10 maximum. Okay, so 10 pieces maximum. So I'm going to keep going because I'm going to assume that you've either stopped the video and then come back. So what we want to do is take one of those strips of paper. So here's mine. And I'm going to say to you, this is a hole. Whatever the length is, we know it's 11 inches, but this is a hole. And what I'd like you to do with that hole is show me a half. So what would you do with this piece of paper to show me a half? Well, that's probably the easy one for you. We just take it and we fold it in half. And I have 2 equal pieces, right? I can open it up and see them. So one of the places in your fractions also says, how can they prove that a half is made of 2 equal pieces? Well, there you go. I folded a piece of paper. I have 2 equal pieces. They're over top of one another. There's no gaps, no missing pieces. So what I'd like you to do now, when you open it up, you should see in your fold, there's my fold, there's one piece, here's the second piece, they're both the same. So on yours, I'd like to write 1/2 and 1/2. So go ahead and write those on and then put it down in front of you. And we're going to grab another one and we're going to do a different fold. So once you've got a 1/2 and a 1/2 written, put it down and then grab another piece of paper. So again, I'm using the same length, same long, on this one, just a different color is all it is. So this time I would like you to fold this into quarters. So think of what you did for half. This time I'd like 4 equal pieces. Okay, so go ahead and fold it. So we'll obviously start with the half again. So that gives me 2. And now I'm going to fold it in half again. And that should give me 4 equal pieces when I open it up. So go ahead and open yours up. Kids do like the activity of folding because it's fun, it's interesting. They haven't done a lot of it. And then they can do their marking too. So now I have 4 equal pieces, 1, 2, 3, 4. And I want you to mark 1/4 on each one. And put it down right underneath your 1/2 that you just did. So not only am I going to get to that understanding, I want students to tell me that understanding. I don't want to share that with them because truthfully, it will mean nothing to them if they don't have a good sense of fractions anyway. Then the paper folding we're doing is also getting to unit fractions. It's also getting to counting by unit fractions. And we're just hitting all these outcomes, a whole bunch of them at the same time. All right, got the quarters marked, put it down and grab another piece of paper. Again, same hole, mine's pink this time. They don't have to be different colors, it's just that's what I have in front of me. And I'd like you to go to 8s. So think of how you got to quarters. I would like you to use your thinking of getting to quarters to show me 8s. I want 8 equal pieces. So go ahead and fold again. So I will be folding in half. When I fold that in half, that's how I got to my quarters. That gave me 4 pieces. So if I took the 4 and divided or folded it one more time. When I open this, I should have 8 pieces. 4 pieces were now folded in half, so doubled. So I should have 8 pieces when I'm done. And when you open it up, sure enough, you'll have 8 pieces. So what I'd like you to do is the same thing. Put 1/8, 1/8, 1/8, 1/8, 1/8, 1/8 on all pieces. And put that one below your quarters. And I think probably you've learned enough about me as we've been going through these series to know that I hate telling students answers to things. I would prefer them to discover and tell me. And if I don't, then maybe I have to ask a question differently, or maybe I need to do another model. But I might ask at this point, well, you got 3 strips of paper sitting in front of you. Is anybody noticing anything? Just see what they come up with. The center line is always folded in the same place. Okay, that's good. Anything else that you notice? Well, they're all different size pieces. Okay. If nobody's getting to the fact that the more pieces I want to see, the smaller they're getting. So the more folds that we have put in here to create a unit fraction, the smaller the unit fraction is. Why is this such an important understanding? Because if you think about students who are still a little bit lost in fractions, you ask them the question, which is greater, 1/4 or 1/8? And they quickly say it's 1/8. And they're thinking in whole number terms. They're not thinking in fractional relationship terms. So yes, 8 is larger than 4. But when I ask you to take that sheet of paper and divide it into 8 pieces, it's still the same length of paper. That means that those pieces to get all 8 in versus where I only had to have 4 before would have to be smaller than the 4 pieces were, because otherwise I won't get 8 folds. So if nobody comes to anything close to that conclusion, just say, great, everything you found is really good. Let's grab another piece of paper. And I'm going to do the same thing with you. And I'm going to say, let's start, same hole. This time I'd like tenths. So 10 equal pieces. We're going to run into a snag, but go ahead and start. So I want 10 equal pieces this time. Okay, so you might have already discovered what might be the problem. There were 10, I wanted 10. When I fold it in half, that would mean that each side would have 5 unit fractions on it. But if I take this and it's 5 long and fold it in half, I'm going to get 2.5. That doesn't work. I need whole numbers, not part numbers, because kids aren't doing decimals here. So the problem is the fact that this is now an odd number in length. Even though I'm going to get an even number in the end, What I have when I folded it in half, it became an odd number. We said we wanted 10, folded it, got 5. So what you need to do, and do it as an adult, not as an estimate for a child, look at your 5, put your finger approximately where you think 1/5 is, ballpark it. You're not using a ruler here, just eyeball it. Where do you think about 1/5 goes? I'm going to put my finger, I think it's about there. Wherever I think it is, I'm going to fold it over on top of itself. What I'm doing is I'm changing my length of 5, and I'm guessing what 1 unit would look like, and I changed my length now to 4. So that piece that I guessed on, here's the unit piece, I folded it over, now I have a 4. Well, we know what to do with the 4, that's easy, right? We can take the 4, fold it in half, that will give me 2, and when I fold it in half again, I get 1. And this is where you're going to check to see whether this is where you'll find out if you estimated as an adult how close your 1/10 was, because it'll either fold over a little corner of a piece, and that just means yours was too long. Okay, open it up. Regardless if they're not exactly the same length, do you have 10 pieces? So count them. And if you have 10 pieces, although they may not be looking exactly the same, go ahead and label them 1/10, 1/10, 1/10, 1/10. And put them underneath your 8s and ask that same question. What do we see now? Students will come up with the right answer to this. They may not word it in the way that it's worded in our curriculum, but their intent will be the same. So they will eventually come up with a statement that says, well, the more pieces we have, the smaller they get. So then I can go back to that statement and say, let's unpack what that wording was again. That's exactly what that's meaning. It's saying that the more I want of unit fractions within a specified area, the smaller the chunks are going to be. The less I have, the bigger the chunks are going to be. So you could hold up the 10s and the halves. I only wanted 2 pieces and a half. In 10s, I wanted 10 pieces. Well, something's got to give, and it's definitely going to be the size. We also want them to understand that what they found was unit fraction. This is a unit. This is 1/10, 1/10, 1/10. I could skip count on a number line from 0 and get to 10 over 10 or 1. So this is that same thing that we've been doing all along. So this is another way that you can go back and revisit unit fractions, especially if you did it a while ago. And they're going to think this is all new, and probably the paper folding will be. But the notion of the outcome that you're testing and that you're going through is the same outcome, just another new way for them to see it. Another way for them to get some strategies and some ideas about to understand what that looks like. And then you can have that conversation about 1/10 and 1/4. Which one's bigger? Which one's less? So what you see here is if you forget along the way or you don't have access to the video, this is again, how do I change a strip into 8s? Well, we did that one just by fold, fold, fold. And then 10s, fold in half, but then I have to get rid of the odd number. So if I asked you to find 6, and you took a piece of paper, you should be able to do that one on your own. This is my hole. When I fold it in half, if the hole was going to be 6 pieces, you already know what's going to happen. When I fold it in half, I'm going to get 2 3s. Can't have an odd number. What do I have to do with the odd number? Well, eyeball how much you think a third is and fold it over. That gives you 2. 2 can be folded into 1. Open it up, should have 6 pieces. And if you're getting better at the eyeballing, you'll probably get that part almost dead on what it should be. So there's no fraction that you can't fold on a piece of paper. Obviously, if you say I want 20, then you have to be prepared that they're going to have very small pieces. And eventually the number of layers that you have on paper to fold becomes problematic. But if they understand any of those, they can do a 7, they can do a 9, they can do an 11. Like those are doable because I know how to handle the odd number. That routine will never change. So this gives you a way, again, to talk about modeling of unit fractions, counting by unit fractions, finding a whole by unit fractions. So you could even have up on the board here a statement like this. And this could be where you start. In fact, if this was me, I would have these 2 sentences up on the board and say the blank, the denominator, the blank, the equal pieces. So the smaller the denominator, the larger the denominator, right? Those are only two options I have. So we could say, we'd like to be able to put in some words into these blanks to make these sentences complete. Let's do some folding. And now ask them, what would you fill into these? So the smaller the denominator, the larger the equal pieces. The larger the denominator, the smaller the equal pieces. That's what that understanding was getting to. So we can put this right up. Here's our carrot. This is what we want to be able to solve. They can keep looking up. We keep doing strips with them and say, anybody still have any ideas about what are you seeing happening here? And now that you see what's happening, how do you think we could fill these in? And let them have a chance of doing that. There are other places that you can do this. If you go to Toy Theater, and I will go there just to show it to you. So Toy Theater it's a site that has lots of different things on it, but there's some of them I'm not finding are necessarily as good as the other ones that we've been using. But here you have fraction bars, and they're excellent. The fraction bar says this is the whole. So I've got 3 wholes here that I can compare. So again, if I ask a student, which is larger, 1/5, 1/4, or 1/3? Now, if I understood the paper folding, I understand what we filled in the blank. That's a no-brainer. I'm going to be able to answer it for you. But what if I haven't quite yet figured that out again? Maybe I need to do another round of paper folding. The equivalent of the paper folding is right here on this screen. So you can adjust the numerator and you can adjust the denominator. So I said 1/5. So this is this line divided into 5 pieces. I can bring it up. I also said 1/4. And then we could even say, what do you think's now going to happen? What's your answer going to be before you even show it? So they should be able to conclude that 1/3 ends up being the larger. You could use fraction strips, same idea. But this is one way for us to have another place that they can go and build. And you have quite a bit of flexibility here. They will get very, very small, but I believe, you may have to check it, but I believe you can go up to 50 in the denominator. And they don't always have to be unit fractions, but really that's what we're trying to get at here. We're trying to compare unit fractions. So that's our conversation. But if I said to a student, which is greater, 2/5 or 3/4? Okay, for some students, they still have to think, I have to do 2 1/5 counts, 3/4, I'd have 3 1/4 counts. Now they should be able to, if they understand it and the wholes are the same, they'll probably figure it out just by thinking of the hops that they have to do. But maybe they want to put it here. So you can adjust both the numerator and the denominator. Okay, so that's a great site actually to work on. We also have over here that the name of a fraction describes the composition as a number of unit fractions. So what that refers to is if I name for you 6/7, and I say to a student, can you tell me how we could get 6/7? Not tell me what unit fraction. I want them to tell me that I could use the unit fraction 1/7 6 times. I could add it, I could skip count by it on a number line, but I had to use 1/7 6 times to get to 6/7. All right, so that's what that line refers to. So we want them to practice using unit fractions to come up with that. And then you can give them really bizarre ones. You can say, okay, here's a really weird one, like 113 over 257. Not that that is a significant number of anything, but the challenge would be, how could I get to that number? They don't know how to add fractions yet, so it's not like we can do multiples of something. So in this case, it would be that unit fraction that we're talking about, and they've got 100 of it, right? So again, do they understand or don't they? One of the other questions I have for you here is, down at the bottom, it says compare fractions that are benchmarks of 0, 1/2, and 1. So if you think of those lines that we did, you think of the strips that we did, those were all 0 to 1. That was our whole, that's what we said. And whatever pieces we wanted in between were the unit fractions that created that whole strip. So whether it was 1/10, 1/4, 1/5, didn't matter. So here, my question to you on the side is, what if I want to go one step? So remember, transfer is, can I take what I've learned and transfer it to a new situation? So if I take a string and I just give them a piece of string and say, your string is the whole, then they know that the one end is 0 and one end is 1. That's my whole. And I say to them, show me approximately where 1/4 would be. Then if they paper folded, the string should be no brainer for them, right? Take the end of the string, put it over, hold it up, I've got a half. If I take the fold where the half was and put it back to the beginning, I put a little marker there with my finger or a clothes peg, those little clothes pegs you can buy at Dollarama. Oh, I just found another fold, and that fold will be 1/4. Each one of those will be a quarter jump. So they should be able to transfer their learning of the folding we did with paper into a scenario of finding any fraction on a piece of string. Just give us a piece of string, give some kids yarn, give some of them twine, give some of them whatever, right? So that they don't even think it's the string that makes the difference. It doesn't matter. It's just a piece, a length of something. And you're telling them that one length is 0 and the other end is 1. Now, if I wanted to go one step further, how could that notion that I just did of paper folding help me if I gave you a piece of string and I said, I want you to put the number 79 on if your string goes from 0 to 200? They should be able to transfer that learning that they just did or have done in the past. So if I take my 200, this piece of random yarn you gave me, fold it in half, I know where I can put my marker for 100. So I know where 100 is. So now I can try and guess about where 79 might fit. Certainly not right beside it. Certainly not way over on the other end closer to 0. So they should have a reasonable estimate about where 79 would go. Now, some students might even say, well, I could fold the 100 in half and that would give me 50. So now I know where 0 is, 50 is, 100 is, 150, and 200. That's pretty good. Because if you think about it in terms of money, now I know where 50 cents is and I know where $1 is, and you're asking me to put 79 cents on. That's pretty close to 3/4. Where do I get 3/4? Well, it's halfway between 100 and 50. Okay, do I have the capability to do that? I sure do. I can find the halfway mark, or I could have found quarters along the way. So again, just put it in terms of money, change the number to money. But the idea is that have they transferred what they've learned on just finding unit fractions to even using that just on a normal whole number line. So when we were looking at these kinds of questions, this is where we want to say, how could I get 4/6? I could have 4/1/6 hops. How do I get 4/8? It could be 4/1/8 hops. How is 4/6 and 4/8 the same? Well, the numerators are the same, but the denominators are different. The unit fractions are different. And you have a part in there where the numerators are the same. How do you compare the fractions? What could you talk about? When the denominators are the same, but the numerators are different, what do we have? So denominators are the same and the numerators are different. So how are 3/6 and 4/6 related? Well, they're both hops of 1/6. One only went 3 and the other one went 4. One is at the halfway mark. If you want to talk about equivalent fractions, one went beyond the halfway mark. So this is the kind of conversation that we want to have with students. The other piece that we did do some work on, but I want to revisit again, was that work about angles. And so in your measurement unit, we talk about students interpret angles. And they need to have an angle, what it is. First of all, what is an angle, right? An angle is just, you have two rays and they're connected by a corner. People call it a corner, but the proper term would be the vertex. So I have usually arrows on the end of them, typically, but not always, but they usually do, because they could go on longer than what we've drawn them. And we should be able to find that a definition is applied to any size of angle. There are always going to be two pieces to it. And then based on where those two arms go, I get special names. In grade 3, they're not jumping into protractors. What they're using is common angle, the right angle. And we do talk about it being at 90 degrees, but it's not so much about the importance of the 90 degrees as much as this is what a right angle looks like. Where do I see them in the classroom? I see them in the corner. I see them where the wall meets the floor, assuming everything is perfect, right? So where you have a counter, where you have a door corner. So you walk around and show them all the right angles that are right in front of them all day. Are there any in their book? Are there any in their pages? Where else can they find them? And literally what we want them to do is be able to take a picture of a right angle. So they could cut one out. You could get that from the math kit, cut it out and they're going to use that as a measuring tool. Is what I'm looking at right now a right angle? So when I put that right angle on my book, on the corner of my book, I see that it probably is a right angle. But what if I opened my book and used the cover and then the first page rule that's in there, and I stand it up to see how would I have to stand it up to make it a right angle? What would happen if the book opened a little bit more? Well, now I see when I stand my right angle picture in there that it's actually bigger than 90 degrees. I don't want them to measure how big it is. I want them to know that it's bigger. Or flip to that, I push the cover so that it's like this. So here's my right angle when I show the picture, and I can hold it against the book, but I see that the cover's over here. So it's actually smaller than 90 degrees. So it would be reasonable to show them what an acute angle is and name it. They're going to do more work with it, but I can name that an acute angle is actually smaller than 90 degrees. It falls somewhere inside here. Or what we call an obtuse angle is actually taking this and moving it out this way. So it went beyond standing up perpendicular. In other words, giving me that right angle. And then there's that what we call a straight angle. So this is the little piece that they want to walk around with or have a comparison to. And they don't necessarily have to have an angle like this drawn out. If they understand what it is, they can even just take a book with them and then send them on a quick scavenger hunt to write down on a piece of paper all the different right angles that they found in the classroom, or let them go out in the hallway because their lockers are going to give you that. There might be tiles on the floor that they can see them. Like, where did they find them? Let them just be observant mathematicians and go out and have a look. So find 5 examples in each of these if you wanted them to do all of them, but really this is your focus, is the right angle, outside of the classroom, wherever, out in the playground, right? All those different things that you have for climbing apparatuses and swings, and where's a right angle? Do they see one that's bigger than a right angle? Do they see one that's smaller than a right angle? Right? It's just a fun way, but very, very much tied to what you have to teach them. So when we talk about interpreting 2 angles can be compared, that's what that's talking about. Go out in the real world, find shapes. Is that angle bigger, smaller, same as 90 degrees? So if I go into geometry, that was measurement, but now let's tie it in to geometry at the same time. I'm still trying to compare, do shapes that I find in geometry have right angles in them? Do they have bigger than right angles in them? Do they have smaller than right angles in them? So that's the conclusion that we want to do. And that's why I cut and pasted these in here along with your angle measurements, because it leads right into your geometry. So I could be talking angles and slide my geometry outcomes in at the same time. So investigate relationships between the sides of polygons, including perpendicular, parallel. So, right, if I had a square, if I had a square, I would see that the sides are all the same length. I could take a piece of paper, mark it off. I don't need a ruler, and just measure it, see that they're all the same. And they all form right angles. Okay, that's the definition of a square, all same sides. It's called a regular quadrilateral. So remember that your regular polygons, something to be defined as a regular polygon, means that all the sides have the same length all the way around. And all the angles in that shape are the same, not always right angles. In a square, they're all right angles. So some people say, well, a rectangle is a regular polygon. And the answer is a rectangle has 2 sets of parallel sides. They're both, the long sides are parallel, they'll never meet, they're exactly the same length. The short sides are parallel, they have exactly the same length and never meet. But that's not a regular polygon because all 4 sides don't have the same measure. So it is a quadrilateral, but it's not a regular polygon or a regular quadrilateral. So that's one of the things that they have to figure out is what are the regular shapes and what aren't they? And so you could go into a number of different, you could take out pattern blocks. Which of the pattern blocks would be considered, they're all geometric shapes, but which ones are regular? So the hexagon, the yellow hexagon is all the sides are the same length. All of the angles in there are the same measure, but they're not 90 degrees. So I could use, if I just want to compare to 90 degrees, say just to show you as simple as it could be. And again, you could use pattern blocks for that. If you go into Mathagon and click on Polypad, I have a whole bunch of shapes in here, and nicely done because everything that's up here is a regular one, even though they don't say that. And everything down here is irregular, obviously, because they don't even look like they're the same length on the sides, and the angles are not all the same angles. So if I wanted to check to see whether or not something was regular, it means that I need to be able to measure the sides. And again, a piece of string, how long does it from here to here? Just keep your finger on it, your thumb on it, and then are they all the same? Well, that checks. And then all the measures, are they the same? So there's ways for them to go in and check those out. So these ones are good definitions or examples that they could use for regular. And any one of these can be enlarged, by the way. They don't have to be small like this. You can take the scale, and if I just change the scale to 4, it'll be 4 times the original. This will make it easier for projecting, right? So I can do that work there. And then I can even grab a square, put the square in here. And I see, is that angle a square, a corner? Is it a 90-degree angle? No, it's definitely going to be bigger than that, but it's not 2 right angles put together. It'll be less than that. So there are ways that I can figure that out, and you can do that with your pattern blocks. And we did that in another session already. These ones are also polygons. They're all polygons. This is a quadrilateral. It's got 4 sides, but it doesn't have 4 of the same, doesn't have 4 angles that are the same, etc. Okay, so this is a good place to do that kind of work, but you probably have lots of shapes in your classrooms that you can use as well. So here's an example of the regulars. Here's an example of they're all polygons, but they're not regular. So that's the difference between these. There's lots of places too, when you go into your geometry, you're talking about transformations. We did that already, but I just want to show you these links are places that you can go to. I'll go through one for now. Interactive maths. When you come down here, you've got your reflections, rotations, and translations. So I should be able to take any shape and move it on my grid. And as I do that, I might want to go down to the challenge. I could just start with that one. So when I go in to get rid of the ads, I guess, you'll have a descriptor. The blue shape has been reflected. So we're just doing reflections in the red line to create the green shape. So where would you move the red line to place the green shape over the purple shape? So let's go and have a look at what they're looking at. So here it is. We see that I put the red line here, and the blue line got reflected in this mirror and became the green, or the blue triangle, sorry. And again, you could review with the students. Remember when we did this, what did we have to check for? Well, here's the mirror. It's 1, 2 to this vertice. It's 1, 2 to this vertice. So to be a mirror image, I have to have the same distance on the other side. I could find this point by just counting again, 1, 2, 3, 4, 1, 2, 3, 4. So then they can grab the pen, they can put the red line where they think the red line is going to be. And remember, they're looking for it to be this one to go right on top of this one. How are they going to do that? Okay. There's lots of different possibilities here that they can play with. There's lots of different opportunities for reflection and rotation. Transformations, level 1, that's a good one for them to start at. Here they're getting a shape, not a regular polygon, it's just a polygon. And they're asking them to use the y-axis, draw the reflection of your shape in the y-axis. So if I know that this corner is right on the y-axis, that the reflection will be there too, I just click it on, and that gives me my first point. And I know that I went 1, 2 this way, so I have to go 1, 2 this way, so I'll put my next dot, and now I built my first line. Then I went 1, 2, 3 up, 1, 2, 3 up, next line. I went 1 over in, 1 over in. I went 1 down, 1 down, 1 over, 1 over. So here is my reflection. So I can start again if I made a mistake. I can show the answer, and the answer is exactly as I've got it. So I did it right. If it wasn't, it would show us. So they can go through and do these. And the nice part about this particular level one is if they are doing it on the computer, as soon as they sign into level 1, no two students get the same set. They move them all the time. If I go in and check level 1 again, these will all be different. So it just gives you unique places for the kids to work. They can't really long neck and just do, but they could do them in partners for sure. Okay, so just some sites to go to. This one is another one, and I'm suggesting go to sections 2 and 3. That's grades 2 and 3 in there. both of those grades would work for the things that you are doing. All right, so the other piece that I wanted to unpack was statistics, because we said we would leave that until the end. So in grade 3, well, maybe we'll backtrack even a little bit. In grade 1, students are asked to generate a good question, get some data for their question, and then plot their data onto a dot plot. They're not asked to interpret or explain or do anything of that nature. Now, in theory, that's where they're supposed to leave it. We've talked about that with the grade 1 teachers and said, you might want to have a very brief conversation. If you're going to take the time to do a dot plot, then you don't just walk away from it. You want to say, what did we see? You know, was there one line that was higher? And at least have a quick conversation about what happened when we plotted our information. In grade 2, they do the same information, but they now are also tasked with making sure that whatever they're graphing is appropriately labeled. And that is the only place that all of the components of any graph that a student does is articulated. The name of the graph, the labeling of the graph, the units of the graph, all of those pieces that we always want on a graph. So by the time they get to grade 3, we are assuming that's been done and they know it. And they're not going to say in here anywhere to review that. But you're going to have to know that maybe your students don't have that from previous knowledge. So you may have to do some of that work with them this year. So just knowing, that's why I'm telling you what the grade 2s are doing. They too don't do interpretations per se of anything that they gather their questions on, but you do in grade 3, okay? You actually go through and interpret and explain the representations. You explain why you used the graph that you did. You explain how that graph represents the data that you found. You explain what the conclusion might be. In grade 4, they do analysis, but really you're edging on that doorstep already too, right? You're trying to make some kind of a, this is what we found. Most students in our class like blah, or most of the students, or it was very close. Most students like this and this. So at least the interpretation of that needs to be reflective of the work that they've done. So they are collecting first and second-hand data. So in this case, when I'm doing the work, most of it should be first-hand data, and we really want them to go through and collect it. Ask their question, go get it. But they could use second-hand data. In grade 2, they only use first-hand data. So when I'm looking at, this is your grade 2 summary here, so I won't go through that one again. But when I'm looking at this, where it says representation, connect data to statistical question. One of the things that I have been doing in grade 1 and grade 2 is saying, are we as teachers all on the same page when it comes to statistical questions? In other words, if a student says, define that for me, would you have a definition of what is meant by a statistical question? So I'm going to play the left video for you. We've used that with every group because it just really starts the conversation about, if we're going to do stats with students, we should all know what a statistical question looks like and what it does not look like. We'll start the second one, but I'll leave that one for you to finish at some point in time. It is very appropriate for grade 3. It does go a little bit beyond grade 3, but it does give you an interpretation of when I look at data, what do I do with it? It also reviews what is a statistical question, and that's where I'll pause it at that point. So let's just watch 2 of these videos very quickly.
Welcome to Moo Moo Math and Science. In this video, I'd like to talk about understanding statistical variability. A statistical question is one that results in multiple and varying numerical answers, rather than just one single answer. Let's look at these questions and see if they are statistical questions. What grade did Hannah get on her math test? Is this a statistical question, yes or no? No, it is not, because there is only one answer. We need many different number answers. Next question, who earned a better grade, Frank or Grant? Is this a statistical question? No, it is not, because it is not a number answer. And finally, what grades did everyone in second period math earn on the test? Is this a statistical question? Yes, it is yes, because we get a lot of different number answers. So there you go. statistical questions and variable.
So in short, statistical questions have to have multiple possible answers and they have to be numerical in nature. Okay, that's just a common definition. Again, students need practice of that and figuring out whether, like just those simple examples. The second one offers us a bit more, and I will stop it partway through.
Hey guys, it's Kaylee. This lesson is an introduction to statistics where we'll cover statistical questions and dot plots. Let's get started. You've probably heard the word statistics or its abbreviation stats before. Statistics help us answer questions like who has won the most times in your video game, or how many times and how fast did I run on different days this week. Statistics is the science of collecting, organizing, analyzing, and interpreting data. In statistics, data is very, very important. But how do we collect data? There are a few ways. We can run an experiment or have a survey. But in both of these ways of collecting data, there is one main thing in common. We have to ask a question. When we ask a question to collect data, it needs to be a statistical question. A statistical question is one where you expect to get a variety or a lot of different answers. Which of these do you think is a statistical question? How tall are basketball players? What time did you wake up this morning? How much money do people typically spend on cars? Do you play soccer?
Now, that should be a great place to pause the video and just let them mull over those questions, right? Which question or questions do they think are statistical questions? And so that just gives them a starting point as well. And those are easy questions for a grade 3 student to handle. So then it'll go through and it'll highlight what they are. It'll talk about how we might analyze, how we might get information and go through an example. So I would encourage you to take some time and watch the whole thing through. It would be very appropriate to use bits and pieces of it right off the bat with students when we're starting, just so that we're always talking about the same language about what a statistical question is, so that they know that not every question is a question, but it's not a statistical question, right? So then they need to understand the differences between the two. Okay, let's move on.
Welcome
Hey
to
guys,
Moo.
Sorry, as soon as we put those in, they always start. So here's just some examples. You might want to use those on the board even. So someone went through, here's some secondhand data. They went through and they were talking about with grade 3 students, our favorite sport. And you see that there's an example that comes up. And I see there's hockey, soccer, basketball, and gymnastics. And here were the results that they got. So what does those results tell us? And the other piece is that it tells you, how do I even record my answers? They use tally marks. Is there something else that they would use, right? What kind of graph are you going to use? Is there some different way you want to collect the data, etc.? Or over here, what's the most common type of pet owned by grade 3 students? These are questions you could ask in your own class as a model, right? We have to model them first so that they know what they're going to do with their own question. If you have an event that's happening in the school where you could tie in a statistical question to the event, maybe you have a barbecue every year and tie in something to that barbecue, or you do a special fundraiser at this time of the year, whatever. Like, is there something that happens on a year-by-year basis in your school that you could use to leverage as a statistical assignment where the students could go gather information? Or we go through a couple of examples like this, and then we say to them, you know, what you want to find out? And are they going to just ask the kids in the class, or are there 2 grade 3 classes that they could ask? Are they going to be asking, you know, announcement goes on in the morning that their grade 3 students will be found outside the office in this area, and they have some questions that they would love to have some people come and answer the question to gather data, right? So just make the whole school involved in it, whatever. I also say that if you are in a building, an older school where you use concrete blocks on the wall, those are wonderful to use for your graphs if you want to make a bar graph. So depending on whatever you have available, if I can do a bar graph on a wall out in the hallway, and you mention that in the staff room, everybody can leverage that information. If they're really young, what did they see on the graph? What interpretation? If they're older, what other things how can they analyze it? For those who are doing older students, what's the standard deviation? Like all that stuff, anybody can walk by. We've done that in the past where I was in schools where we had Olympics in one year and we kept track of medals. We also kept track of specific events that were being won, and we tracked how many was happening over the course of the time. So depending on the age that walked by, the teachers would leverage a question based on whatever grade they were in and what kinds of things would be appropriate for statistics or reading a graph or whatever at that particular moment. Everybody could go by. So there's lots of different ways that we can involve students in the gathering and information of stats. If you need an idea or you want something that's a little bit different, or you haven't done anything for financial literacy yet, you could do a stats and tie in financial literacy by looking at this section here called wants and needs. Read it through and see if there's a way that you can leverage the information and the kinds of questions that they look at. Is there a way that you can turn that into a stats question, which then also does your numeracy, your financial literacy component as well? Just a thought. I'm not saying that that's the way to go, just if you were looking for ideas. Remember that we also had this game. I just brought this back on to remind you, we started in session 1 with it, that this is where you could put dominoes. Every student gets their own mat. You can change it to as many petals as you want. Every student puts a domino or maybe a pair of supertizing cards on there. And then what you do is you roll 2 dice. So let's say I rolled a 6 and a 4. And just to warm their brains up, 6 and 4, 6 plus 4 is 10. Do any of my cards add up to 10? Yep, this one does. And if I find one that adds up to 10, I can take it off. But in grade 3, we're not working on addition, we're working on multiplication, right? So if I rolled a 6 and a 4, I would get 24. Are any of my cards, with the way they are, can I multiply the 2 sides of them? And if I get 24 in any one, I get to take that off. The goal is for me to get everything on my petals off before somebody else does on theirs. So that's just a fun way for them to practice their multiplication facts. I've also included just a suggestion for you that there are a number of different, this is a teacher pay teacher package. And if it's something that you're interested in, please let me know and I will send you the link for it. But what I'm not a big fan of worksheets of any kind, but what I like about this is not a typical worksheet. It provides you with a number line, and the number line varies in size, right? Starts in 2,000 to 5,000, 0 to 8,000. Again, using the strategies of estimation. What do I know about numbers on a number line? What do I know about size? How do I figure out where halfway is? Where would I put each of these numbers that would fit on there, right? So this is a great leveraging tool that we can have for students to start thinking. And it's a nice package. I really appreciate the work that this teacher has done. So there are a couple of places. These are all links for you to go to, but I just wanted to highlight a couple of them. When we did Cuisenaire rods, we used the New Zealand resources, NZ Maths, but what we didn't do is just look at the math activities that they have provided for teachers. So outside of the manipulatives, okay, I'm not too concerned about that. What I want to do is look at, you have teacher materials, you've got professional practice, they have videos in there. But if you come to where we are right now, the materials, they have done a number of tasks. So maybe I want to do a formative, maybe I want to do a mini assessment, summative. These can be edited. So go in, have a look, first of all, sort of at the strand that is indicated. Is there something that grabs your eye? Check it out and see if that's something that you could edit, use as is, or gives you an idea, or use as a model, or give students saying, you know, I have 4 things that you can choose from for a question. Whatever unit it's in, and then give them choice of all 4 that what you're looking for. Case in point, the work has been done. You just need to use whatever's there and edit it to make it work for you. The second piece would be, at this time of the year too, you might be looking for some additional assessment questions. These come from archived US exams. Now, I've done some work in the US, and in some of the work that they have done questions that are already leveled. In other words, they're DOK leveled, Now, you may not be familiar with that, so they're leveled based on complexity is what they're looking for. But sometimes we just need a new example, or maybe I need a new picture that I can build a task out of. So I'm not suggesting to use these exams in their entirety for anything, but as a grade 3 teacher who's maybe looking for some new ideas and new things that they can put together, these archived exams would be helpful to you for sure. So there's a number of different books. They're all from different years. They all follow very much the same format. So if you have an area that you were looking for something in, have a glance through, okay? And keep in mind, watch for Imperial, because they are going to use Imperial units. And so although you study Imperial, and it would be fine for you to have Imperial units on your test, make sure it's appropriate place for those Imperial units, right? You did a pretty minimal job of Imperial at this point. Okay, I think that the rest of them you can go through, but those are the two that I really wanted to talk about so that you knew what you were getting. So although we're done our sessions, I just want to reiterate to you, just because we're done does not mean you can't reach out. If between now and June there's something you need, have a question, would like some support in, just email me. I'd be glad to, if I have something you need, I'll send it to you. If not, if you just need a question answered, don't hesitate. It's been a pleasure to work with all of you, and I apologize that we had to defer this one today. I just had a medical issue that had to be addressed. And so thank you so much. I wish I could have said that in person, but I've really enjoyed our journey together. There will be additional workshops that I am going to put on next year. We're not going to redo the start from grade 3 again, but I am going to do what would be the next layer. So now we've done through this course once, and yeah, no, it's not perfect yet, and we're going to learn as we go round 2. But there are some pieces that we could already add on to it. So I will have individual sessions by grade, but there might only be sort of 2 or 3 in the whole year. So just watch for those. And if it's something that interests you, then maybe we'll see you then. So thanks very much, everyone. Have a great rest of your year, as well as a wonderful summer. Thanks again.